Hey there, section 7 of chapter 10. We're still sticking with the idea of area in this section, only we're doing it with a couple of different things that we've done so far. So the goal here, which is worth writing down, is to find the area of circles, sectors, and segments of circles. All right, so that is our goal, that's our objective. You'll find out what sectors and segments of circles are in a bit. Parts of it will be review, parts of it will build off of that review, and there will be a little bit of new stuff here as well. So the first thing is the area of a circle. This is something you've learned before, but it's something you may have forgotten. The area of a circle is the product of pi and the square of the radius. So pi r squared. That's what we've learned for area of a circle. So let's show how that works in problem 1. Finding the area of a circle. So we have I don't know if you've ever seen wrestling, but they do have a circular area for them to be within. And this problem says, what is the area of the circular region on that wrestling mat? How much space does it actually have to move around in? If this whole length right here, the diameter here is 32. So don't use 32 in your area because we need the radius. So area equals pi times the radius would be 16 squared. So I'm going to use my calculator. Really, you can leave it as in terms of pi if you prefer. But 16 squared is 256, so it would be 256 pi, what do we have, feet squared. Or, to get a better idea as to what that is, multiply it actually by pi, and you get 804.2 if we round it feet squared. Alright, so that's how you use the formula for area. Now we're gonna have to know that. You have to know that in order to find these other two things. And these other two things, the first one we're gonna start off with is a sector. So it's a portion of a circle. A sector is a portion of a circle. Kind of like the sector in like you might in a factory there might be different sectors, and you might be in this sector. You might be in that portion of that factory. Well, anyway, a sector of a circle is a region bounded by an arc. We haven't really talked about what an arc is, but it's a part of the outside of a circle. So it's bounded by an arc of the circle and two radii to the arc's endpoints. So if we look at it in visually, we have the arc here. This is a picture. Here's the arc, and then the two radii going to the ends of that arc. And we're trying to find the area of that portion of it. So the area of the sector of a circle is the product of the ratio of the measure of the arc to 360, and then the area of the circle. So we're still using the whole area of the circle, but in order to find that portion of it, we're just finding the portion of whatever that angle would be. So the measure of the arc is the same thing as, if it goes to that center point, is the same thing as the measure of the um, angle that is formed by it. But we can figure out pretty easily what the angle that it would be formed right here would be. And that would indeed be, well, it depends on what the angle is. So that is the measure of arc AB. So it's a 100-degree angle, so 100 over 360 would be the fraction of that circle that you'd multiply by the area. So a couple examples here to see how it works. Let's first of all figure out, so it says find the area of each shaded sector. Leave your answer exact. So if that is a right angle, we're going to find the area by finding a right angle would be 90 over 360, which is really 1/4, but I'm going to write it like this for the sake of using the formula, times pi times the radius squared. So we just have still times 7 squared. So I'm going to just type that all in my calculator and use 90 over 360 as 1/4. So 7 squared is 49 times 1/4 would be 12.25 pi centimeters squared. Or, if I'm actually multiply it by pi and round it, it would be 38.5 centimeters squared. So we're still using that formula for area of a circle, but we're taking a fraction of it. All right, letter B, we're given the arc angle would be 400 or 45 degrees. So area would be 45. I think that's going to be 1/8. 45 over 360. You can always reduce those to make it easier on yourself. Sorry, I didn't mean to put an equal sign there. We are multiplying it by pi, and then we're multiplying it by the radius squared, which would be 10 squared or 100. So I am going to do that 100 there, times, that's 45 over 360. So that gets you to 12.5 pi inches squared. Or, multiply by pi to see in more terms that we can understand would be 39.3 inches squared. Alright, so that would be the area of that sector. We can look at letter C. We'll see if we want to answer it. Find the area of sector QRS in circle R with a radius of 4 inches and the arc measure of 135. Well, that gives us all the information we need. So leave your answers exact. We just need to leave it in terms of pi. So the area would be 135 over 360 is our times, times pi, because we have the area of, that's the angle of the arc, times pi times the radius squared, which would be 4 squared. So 135 over 360 and times 16 times pi would be 6 pi inches squared. There we go. So that's area of a sector. Now the last thing we want to do is a segment. It's a little bit different. It takes both of those two things into account. So what a segment is, first of all. So a segment of a circle, not a sector this time, a segment of a circle, it's way harder to put into words than to visualize. So let's just put it into words first, and then we'll show you the picture. A part of a circle bounded by an arc again, and the blank joining its endpoints. It's the segment this time that joins the endpoint. So to visualize it, we have our arc. So we're looking at a sector, this would be right here. We have the arc, and its endpoints are joined by this segment, not connecting to the center of the circle by the radii, but it's actually just a segment. So to find the area of that, we actually use what we just did. We find the, well, things that we've done already. We find the area of a sector. Then we find the area of this part that's not part of the segment, which would be right here. But it's a triangle. And if you recall, we can find the area of a triangle. Well, this would be right here. Area equals the angle measure over 360 times pi times r squared. This would be, we found the area of a triangle by doing the, if you look back, it was actually theorem 10.8. It was the area of a triangle. Really, if you know the base and the height, you can multiply that by 1/2. Otherwise, it's 1/2 BC times the sine of angle A. I think I have that right here. That is right there as well. Okay, so we can use that way to find the area, and you subtract that from the area of a sector. So let's do a couple examples for that. We'll focus on A and C for this one. So what is the area of the shaded region? Round to the nearest tenth. All right, so we're finding the area of that sector, that segment. Sorry, we have to find the area of the sector first, though. So the area of the sector would be we have a 60-degree angle, so 60 over 360 times pi times radius squared, which would be 18 squared. That would be equal to 1/6 of 18 squared. I'm going to do my calculator divided with, alright, I have 54 pi inches squared. And I'm going to subtract the area of the triangle. The area of the triangle, we have an angle, and we know that if this is a radius, then this one also has to be 18, because that's also a radius. So we'll just take the area of a triangle would be equal to 1/2 times 18, times 18 again, times sine of the angle in between, which would be 60 degrees. And when you do that, so it's round to the nearest tenth. Alright, we can do that. 0.5 times 18 times 18 times sine of that middle angle, which would be 60. And I get about, and again, rounding right now is not the best, but it'd be 140.3. And subtract that from the sector. So we have 54 pi minus that. And I ended up getting 29.3 inches squared. Alright, hope that works out. Hope that makes sense. But that's how you use that formula. Now, last one we're going to do is letter C. It starts you off. We have to do the whole same process because we're finding the area of a segment, but we're finding the area of everything else other than that segment. So I might say find the area of the circle and then find the area of the segment and then subtract the two. So I'm going to do three things then. I'm going to find the area of a circle. I'm going to find the area of the sector. And then I'm going to find the area of the triangle. All just to find the area of the shaded region. Because the area of the shaded, I think, will be the area of the circle minus the area of the segment. Alright. So the area of the circle. We have a radius of 30, so it's going to be pi times 30 squared. We'll just leave that as 900 pi inches squared right now. Area of the sector, so that would be this whole sector we're going to have to find by finding the segment. So we're going to find the area of the segment. So I'm going to find the area of that segment, so that would be, sorry, the whole sector would be 120 over 360 times pi times 30 squared. And then I'm going to take that and subtract the area of the triangle, which would be same thing, only we're going to do 1/2. The two sides would be 30 because they're both radii, times the sine of that angle, which is 120. And that would tell me, I'm going to do that all on my calculator because that's too much to write out. So it's 300 pi minus, so the first part is 300 pi. We've got all of that. And I end up getting for that, that is going to be 552.8. And I didn't leave it in terms of pi right now, but that would be inches squared. Oh, so in order to find the area of the sector, I should have said, oh, that's right. That was actually the area of the segment. Whoops. Alright, so I used the formula for the area of the segment, found it, and now I'm going to subtract the two things, the area of the circle minus the area of that segment, and I'll get the whole area of the shaded region, hopefully. So, 900 pi, which is going to be like 2700, or more than that, minus 552.8, and I get 2274.6 inches squared. So if you're not sure on any of those parts, make sure you ask next time you're in class. Otherwise, what I'd like you to do for next time is actually answer these two closing questions. All right, have a great day.